I guess first I'm curious, how many people here are scientists? Scientists, like raise your hand if you consider yourself a
Yeah.
scientist. And how many people are like founders? Cool. Okay. Good mix. Yeah. So hopefully this will be more useful, more interesting. Is if we just explain kind of our story and how we got started. If you're not familiar with Experiment, or how many people have here heard about Experiment, or have seen it before? Sweet. All right. Good number. Yeah. So Experiment is a crowdfunding platform for science. We help researchers by letting them create projects which anyone around the world can directly contribute and fund. Um, we've funded close to like 400 projects now. Over $5 million have been pledged through the platform. And we've started in 2012. So I wanted to ask Cindy who we were when we first met.
So before me and Denny met, I was a scientist. I worked in a bioengineering lab at the University of Washington engineering immune cells, specifically dendritic cells, if any of you guys are immunologists. Me and Denny met at a college party during our undergrad, because Denny challenged me to a game of Super Smash Brothers, and I won. And then we also worked on a research project together, designing a therapeutic for anthrax.
Yeah. So our past lives, it is really a total accident that we're up here talking, because we were scientists and we had no clue of like what startups were, what technology was. We were big fans of the internet and users of sites like Kickstarter and Kiva. But I was on the track for like finish grad school, do a postdoc indefinitely, maybe hopefully one day become a professor, but that whole academic track. And so I was also working in synthetic biology, so the lab that Cindy and I both worked in was actually the lab that developed a lot of the technology for the last talk. So specifically, we were doing protein folding. And it was actually our senior year of undergrad that Cindy and I worked together on a project where we basically developed this enzyme therapeutic for anthrax. So anthrax has this protective coating around it. So we use this video game called Fold It, which is this protein folding video game that it's crowdsourced. A lot of the skills in detecting like good binding affinity between proteins and enzymes you can't really teach to a computer, but turns out like gamers are really good with it. And so Cindy and I were actually literally the first people who we did what Atomwise is trying to automate. So our first project, we ended up testing like 100 different mutants of this enzyme. One of them worked, and so we ended up taking it to the iGEM competition, which is the world's biggest synthetic biology contest, and that year we won. And so Cindy actually had the idea to continue that research, except in a new area. Can you share that?
So after we went to the iGEM competition, we published the research in the Journal of Biological Chemistry, and the first author on the paper was actually my little brother, and he was a high school senior at the time. I did a little bit of literature search, and I found that the drug that we had created could also be used as an antibiotic for generic hospital-acquired infections, so staph infections. And I went to my professor and I was like, hey, Dr. Byers, I have this new idea. We have this drug that no one has access to, and I think that it can decapsulate the protective coat on the outside of staph that anthrax also has. And he's basically said, look, like you are an undergraduate student, you don't have a PhD, the system doesn't fund people like you. And I was really persistent, and we went back to the other lab, the Baker lab, and spoke with them. And then my professor said, well, if you can get David to put up half the money, I'll put up half the money for my NIH grant, and then we'll let you do it. And if it works, then we can publish it. If it doesn't work, don't tell NIH, don't tell anyone that I gave you this money. And that's how we funded the project. But during that process, we also went and spoke with any scientists that would speak with us, and we basically asked them, do you have a project that you're working on that you really want to do, but you would like never apply for a grant for? And then why would you not apply for a grant for that project? And every single person would say, yes, I have this project that I really want to work on. I've always wanted to work on since I was a graduate student, but I'm never going to apply for a grant for this project because I know the system won't fund it. The system won't fund it because I don't have preliminary data to make this project a compelling proposal. And so we asked them, if we built a website where people on the internet could give you money for this project, would you use it? And everyone said like, yeah, if people on the internet want to give me money for this project, I would use it. And so we took the first 9 researchers that said, put together a proposal, and we're like, you can put this up. We filmed all of them and we put them on a website, and we just put it out there. And
Oh wait, you're skipping ahead a lot.
all right, I told
yeah.
you guys too much.
So yeah, I guess one of the big reasons why we wanted to tell this origin story of like where the idea came from was because that iGEM experience, where it was literally a team of undergrads with maybe one or two grad student advisors, but that experience taught us that really big science can come from anywhere. Like little teams, sometimes not, these super well-funded, what you think of typically as like a big biotech academic lab. And so we were frustrated because we had this experience with this awesome research proposal. No one had done it before. It was viable, but the system doesn't fund, like if you're an early stage investigator, or if it's interdisciplinary, or if it's risky. And so that's how the idea came about. At the same time, I should mention, so is anyone familiar with like social microfinance, or like Kiva, for example? So that's also part of the inspiration of the idea, because social microfinance works really well in that, like with websites like Kiva, you can amass small microloans, and then there's a lot of kind of good lessons when it comes to encouraging good social behavior, tying together communities like through the internet. And we figured like there has to be a way you can combine this with scientific research. Like how do you bring the public closer to actual science? So that's what happened. And so the very first version of our site came about because a hackathon event called Startup Weekend. And so this was something that while we were just getting started, I don't know if anyone's done like Startup Weekend or a similar like 2-day hackathon. As scientists, we didn't know how to code, we didn't know design, we knew nothing. And so we attended this event, pitched this idea, put together basically a very poor prototype, and that was the V1 of Experiment.
Or it was called Mycorrhiza when we first started.
Yeah, cool. So I do have, I took notes of things that I should bring up. So it was probably 6 months after that experience that we put together a team of engineers, and our very first founding team was probably like 7 people. And so for our first year and a half of existence, we were working out of a library at a college campus. And it was kind of a struggle just in terms of like, we knew we were a startup because we had a product launched and we had people who wanted to use the site, but we didn't know like what happens next. So unfortunately we didn't have like IndieBio around in Seattle where we'd started. But we knew that there was this like burgeoning science startup community in San Francisco and the Bay Area. At the time, companies like Science Exchange and Mendeley, ResearchGate, academia were pretty big, so we knew that we wanted to be a part of that. So we figured we should probably move to the Bay Area. And so that was the summer of 2014?
2012.
2012. So yeah, I wanted to talk about YC, getting into Y Combinator. So in winter 2013, we applied and went through Y Combinator. That was an invaluable experience for us, just in terms of like learning what it takes to like build a community, build a product, grow really quickly. We actually applied several times and were rejected. But it was actually, so one of the fun stories I wanted to share about Y Combinator was that when we were in Seattle starting off, we always kind of knew that we were underdogs. We were undergrads, like, without PhDs, we had zero tech background knowledge, and so we always had to come up with kind of like small things that we could do to either like hustle or get us in the door, or figure out how to reach a bigger audience. And so one of the things that Cindy did early on was just for fun, we would collect like really old issues of National Geographic. So like we had every single issue from like 1960 to like 2002. And when we would go into meetings, we would bring like their birth issue of like their month and year that they were born, and say like, this is what science looked like when you were born, or this is what the world looked like. And so for when we got accepted for an interview for Y Combinator, they said that, well, we'll cover your costs for travel, so you guys can like come down to Seattle. And we figured, well, since they're doing that, we should just go there and not come back. We'll stay. And then for the interview, we actually like there's different tracks, so you don't know like who specifically you're interviewing with, but you know like the partners that you're speaking with. So we actually got all of the issues for every single YC partner at the time, which was like 13 people, and we just had them all with us in like this sports duffel bag. And so for our interview, at the end of it, like it was 10 minutes. We thought we did horribly. I thought we weren't going to get in. But then right before we left, we turned around and like gave, it was Jessica Livingston, Paul Graham, Robert Morris, and Trevor Blackwell. They're like issues of National Geographic. And so like this is what science looked like when you were born. And I think they liked that. I think that's why they accepted us. Um, and so
Never know.
yeah, that was winter 2013.
Huh?
What else has happened around that time?
So in winter 2013, during the first 2 months, what we did is we did a redesign of the site, and then we had only funded like 13 projects at the time, and all the other companies were showing like 10% week over week growth. And we met with one of the partners, Kasser, and he was like, "You guys are doing something wrong because you guys are not growing." And he presented a challenge and what he was like, "Well, could you just double the number of projects every week?" And I was like, "Probably not." And he was like, "Well, why don't you just try to do like this week and next week?" So that week we like launched 2 projects. The following week we launched 4 projects, and then we launched 8, and then launched 16, and then launched 24. And we went to demo day. We were on the homepage of Reddit for the whole day, and that growth really helped us raise our first seed round. So we were able to say that we grew the number of projects 100% week over week for 6 weeks. And what ended up happening shortly after demo day is we raised a round of $1.2 million in a course of 10 days. And then we, from there, moved from East Palo Alto up to San Francisco and started to build our team.
So that was the end of 2013, beginning of 2014 that we moved. And so it was actually around February 2014 that we turned into Experiment. So I don't know if you guys are familiar, but we actually used to be called mycorrhiza.com, which was a very poorly chosen name. This probably reflects our ability as like young scientists thinking like what is a cool trendy startup name. So it's a play on the name of a type of fungus that lives in the ground that like supports the roots in the ecosystem, and like all biologists we spoke to like instantly understood what it was that we were doing, but like 99% of everyone else couldn't spell it, couldn't remember it. So we went like 2 years knowing that we have this horrible name. And so it wasn't until that we got lucky with the domain experiment.com, so which is our current home.
How did you get Experiment?
So the story about getting this domain was more of the same of like, so Brian Chesky puts it really well when he says for every startup, there are moments where like things could go very slightly differently, and it completely alters like the timeline of your company or who you are. And so this was one of those moments for us. I had been tasked with finding this new name, which for a founder, like you know, like that's a founder's job. It's a very careful decision you have to make. You have to put a lot of time and energy into thinking about it, because if you pick the wrong name, then that has all kinds of branding implications in the future. But you also want something that's like good SEO, etc., while also balancing like how much it costs.
I was really frustrated with Denny because he was tasked with this probably in like September, and it was January.
And so yeah, we went like several months not making progress on this, and then I was actually like late one night, like at my desk, Googling different domains, and found experiment.com was available, and sent an email, like did a whois search, figured out the owner, sent an email to him, and he responded immediately. And so like 10 minutes later, I'm on a Skype call with this guy who lives on a boat in Canada, in Vancouver, Canada, and it turned out that he happened to be the original registrant of the domain, and he was like at the time like a physics master's student. So he happened to come from academia, and like by the end of this very short Skype call, he was like, "I want to give you the domain because you know I could see it put to good use." And so this was one of those things where if it just happened to be a slightly different owner, I probably wouldn't be here sitting and talking in front of all of you. But we did get a very good deal on that domain, and yeah. And so yeah, I don't know if you guys can tell. This was meant to be just kind of like very honest, like things that happened in our company's lifetime that we wanted to share. We'd also love to like answer questions that you guys might have. There's a lot we're skipping over, and a lot that we could talk about. And then also we do have some like specific examples, so of like experiments and the types of science that actually happens on the site, what scientists use it for, and also how that connects towards impact. Yeah. Is there anything you want to add?
You don't want to finish the story?
Oh, okay. Well,
Well, how much time do we have? Okay.
so one of the things that drives experiment each and every day is we have this thing internally that we call jelly. So a lot of people, especially like scientists, when it comes to measuring science impact, it's a very hard and oftentimes tenuous linkage towards like citation rankings and journal impact. And one of the things that we've found as just interacting with all of these scientists is that how science actually moves forward is this: when you have like two people, two strangers meeting, talking about science, and there's this personal connection that connects. It's a shared spark over curiosity and talking about science. And so if you're a scientist, it's like when you're at a house party and you're trying to explain what it is that you do, and the other person gets really excited. That's what we call jelly internally, and there's all these moments that everything that we do on the site is geared towards that. And so while I think that a lot of scientists try to measure and like kind of cut up all of their outputs and their work in terms of how you measure impact, this is the one thing that's always held true for us from the very beginning, and what drives us in terms of like what it is that we build and how we help scientists. And so hopefully that'll be evident in the examples. Cool. So this is just to show you our progress. So we're in the middle of putting together a really great kind of year in review and capturing our growth over the past few years. But so this is an example of one of my personal favorite projects. So Lil Bub is this famous internet cat that some of you might know. So it's a really cute cat that has tons of like followers. But it was born with a few genetic mutations that give it like a short snout and like kind of these bone defects that make it also have short legs. And so all of these followers, actually some of the followers happen to be these genome scientists in Berlin, and they were curious. They were like, well, what if we actually sequenced her genome and try to figure out what is the cause for, one, what makes her look so cute, but then also we could use this as an exercise to connect this cat's followers and huge community with the actual science behind like genetic mutations and what happens there. And so they raised $8,000 from several hundred people around the world and they're actually like sharing all of the raw data, the sequencing files, like explaining every step of it. They do these wonderful like video updates with all their backers. So this is another project that's much more local. So this is a group of biohackers based out of based in Oakland. And so this project's actually fairly recent, where they're trying to develop an open source protocol towards insulin development. So today there's no cheap generic available version of insulin. It's all kind of locked up in IP behind lots of pharmaceutical companies. So if you guys, obviously you guys know like the Turing Pharma thing, this project is kind of like the big finger to like big pharma companies saying, what if there was an open source protocol for doing this at home? So hopefully one day you could actually develop insulin, like if you're a diabetic in your house.
We learned about this project because of Ryan, actually.
Yeah. So I'm a biohacker as well. This was actually a project I initiated at Counterculture Labs with Anthony Frankel, who's one of my co-founders, and Ron. So this is a cool little project, and expect more. So I don't know if Ron's in the audience. Ron, do you want to give a hint to what's coming next? And we'll crowdfund it with you, Cindy.
The only way you can go from here. Another thing about this that we was really excited about open insulin is that diabetics all over the world really took off on this, that they really enjoyed it, they blogged about it, they talked about it. It wasn't so much that they wanted to like grow some insulin in a jar in their kitchen window and inject it in their arm. It's that they've been using this their entire life, and suddenly they can sort of hold some part of it in their hand. There's a transparency to that. There's an interaction with medicine. And so Ryan and I are going to take that to another level this summer. We're going to be trying to hack the entire pharmaceutical supply chain and try to make it a little more consumer friendly and put people's healthcare in their own hands.
Ron, give him a taste. Which therapeutic area?
Any asthmatics in the room? Only one? There were 50 million asthmatics.
3.
Okay.
Four.
Maybe you don't want to, maybe you're in the closet still about this, okay? It's cool. But there are 50 million asthmatics in the United States. And they're paying, because of various sort of weird loopholes, they're paying $80 a puffer, or their insurance company is, for something that costs $3 to make. So we think that's a problem. So we want to speak with you about that.
And we'll fund it on experiment.
There we go.
This one is also fairly relevant. So this is actually an older project, but something that's relevant today. Thanks, Obama. So some of you might know this. There is literally a federal research ban on anything related to gun control. So it's been the case since like 1998. And so a few years ago, when a researcher said there's this public CDC data set of like teen gun violence, but no one's allowed to touch it because you need funding and you need to like hire people to analyze the data. And so we approached her, and she launched this project where she was able to basically look at teenage gun violence incidents and compare it and connect it with local gun laws. So this is like kind of a real substantial research project. This was a professor at the University of Alabama who was doing this. And so this is just another instance. So really the power of crowdfunding is that it puts research directly in the hands of the public. And particularly when it comes to like how research is funded today, because of the system of like peer review and paywalls, by the time you as a scientist are actually delivering, like you've finished your science or you've created an outcome, it's hardly recognizable to the public. And so this project was actually one that we funded. That was a professor at the University of Washington, an atmospheric scientist, who at the time there was this proposal for a coal train transportation line that would go through like a large residential area, commercial area, and people were concerned about like what would that mean for air pollution. And so this community basically wanted answers and needed data, but had nowhere to turn. And so for this project, they were actually able to fund it directly, be a part of the process, and then in return, they created. So this is the team working on it. A publication which they eventually took to lawmakers to influence the outcome of this project. So if you've heard of the Cherry Point coal transportation line, this is a research effort behind that.
Yeah?
Ask a question?
Yeah.
So before we were talking about sites like Kiva that do microfinance, those intuitively appeal to people, and I think that's where a lot of their successes come from. That economic empowerment is something that feeding their children is something that really resonates with people. Obviously, some of the science here is very tangible, and actually some of it is less tangible. Is there a lot that kind of goes into content generation to make it resonate with people in order to get funders?
So this is a question actually. The question was like, how do you prepare these projects towards different types of projects and different types of audiences? And so we actually get that question a lot, particularly from like life science scientists, or where it's like a really technical project, or people are concerned like, how does trying to cure a rare obscure disease compare against like saving pandas, which are a fuzzy cute animal? Something we've actually found over time is that there are no differences between like what types of projects are more fundable. So like you would think like biology is more fundable typically than like mathematics, but that's actually not the case. And so a lot of what we do is instead trying to pull the science and kind of share the magic of the research project, why they're doing it, why it matters, directly with the public. And so that basically comes down to like science communication. And for a lot of scientists, that's like a new thing. But for a new generation of researchers who are used to open source, used to Twitter and Facebook and blogging, this can come naturally. And so there are scientists who are definitely very predisposed to be good at this. And for the others, we work very closely with them.
What usually happens to a project and its team after, let's say, they're successfully fundraised and met their goals? Is this kind of like a seed, and then they go raise bigger amounts of money?
So a lot of these researchers will use the preliminary data from these projects to then apply for grants. So one example would be a postdoc in Pennsylvania. He took his preliminary data and then applied for an NSF grant and then was awarded a 3-year grant from NSF. And they are also put in outstanding category, which is this new category for NSF. And we heard that the program officer actually showed his lab notes from experiment during the review committee.
The other thing that's happening more frequently is these researchers are directly like publishing their data as peer-reviewed articles. So out of the like 400 projects we've now funded, there's been something like 30 peer-reviewed journal articles have come out of these projects, like 70 conference talks, and about 90 academic posters. So it's basically fitting into their traditional like science workflow. Yeah.
It's a curiosity. In all this research, did you feel pressure by lobbies?
Do we feel pressure?
That's a good question. So the question is like, could lobbyists use this, I guess? So one of the big kind of like core beliefs we have with experiment is transparency. And so there's a lot of transparency between the researcher and their backers in terms of like the process and what's happening, but also in terms of like all of the backer names are publicly visible. So theoretically,
But
you
can
could
donate
have,
anonymously.
yeah,
You can donate anonymously where it doesn't show up on the page, but the researcher will always know where the money's.
but we've not had an issue with like an agenda-driven research project. That usually doesn't happen.
Do you guys have any metrics on like how the projects you funded small to get research off the ground that go to bigger grants, like those awarding, dollars awarded to say like we've turned this into this into this? That would be really interesting.
Yeah, so we do have a lot of that interesting data, but we've never looked at specifically that. Another good metric, so when it comes to impact, is by some estimations, it costs the NIH or NSF typical like grant-funded research about 40 to 100K per science publication. And so on experiment already, we're at like 35K per paper. So your money goes further than like a traditional like tax-funded like NIH research project.
What are the examples of people who back projects? What are the, sorry, I've lost the word.
Like
So
demographic?
Kickstarter, you get something from it, right? You, I don't know, you get a piece of technology or a t-shirt with your logo. What are the examples of such things?
So in terms of who the backers are, they're actually basically people like you. A lot of them are scientists, a lot of them come from like tech backgrounds, but a lot of them also are just like fans in general of science. And so we don't actually, like we don't have a good like archetype for who these science funders are, because we've always felt these projects can connect with anyone and any audience, and it's just a matter of like how do you get real science in front of humans. And so that's something that we haven't really like ever tried to look at in terms of the backer side. We just focus on like how do we get more awesome research ideas.
But what do they get?
Oh, and in terms of rewards, so the main like feedback loop is updates on the site. So researchers are sharing their data, their protocols, their methods, all of their process. A lot of them are sharing like preprints and proposals that they're sending. So it's actual science output that the backers are receiving.
One more question.
How would somebody as an individual, is there a way to say, hey, I want somebody to do a paper on this topic, and I'm willing to fund it or half fund it or something? Is there some mechanism for that?
There isn't right now, but we're starting a grants program. So our first grants program will launch in a few weeks, and it will be around marine mammals. So what we've done is we put up a grant for $2,000, and we will be launching roughly 20 projects that all focus on marine mammals. And it is a pilot project that could turn into a project where you could say you want to fund a very specific topic, and then we could help find the projects that would satisfy whatever criteria and help fund those projects.
Thank you, Cindy and Denny.
Thank you.